Okay, we should be live here. Does the chat load? Yes, it does. Perfect. Good morning, folks. You know, I probably should be doing other stuff, but I've been having a fun time working on the visualizer, and I figure we may as well just try to get like a full prototype today, because I think I can do it. I will take at some point. I'll probably take a short break today to do a quick RL tutorial whenever we have a decent number of people watching, so I can get some feedback for tomorrow. Because I'm gonna do the exact same thing for an academic lab, and I figure why not try it on my viewers first. All right, so where we left off last, we just need. Actually, we don't need any tabs of this window, and we don't really need any tabs. We'll keep one tab of this window. This is Constellation. I haven't even themed this thing, and damn, this is so cool. This thing looks so freaking cool. It's not even done yet. Okay, so things that we have to do. Yesterday I mostly fixed up the ticks. Hello, E10. So I still have to theme this and stuff, but are there any core missing features at this point? I think the only thing that is missing is the data analysis I was going to do on this big plot over here. That's pretty much it. Oh yeah, and I guess if I want to stretch this cloud of points, I could as well. But like just being able to look how fast this thing is. Look at this. Isn't this cool? Love me some high perf software. This is like completely unoptimized as well. This is literally just the base performance that writing stupid C code gets you. It's literally recalculating all these plots every frame, like no caching, nothing. Python for MVP. Welcome, one character username. Can you elaborate how you will use the viz to improve RL? So look at this thing. First of all, this is the largest scale. I'm pretty sure the largest scale RL viz ever done. At least definitely will be when I add in the rest of the environments to this, because I only have half the environments plotted right now. So we have at least 1,200 experiments per environment across a dozen environments. They're totally different environments as well. They don't belong to the same suite or anything. There's quite a bit of variety among them. And we're going to be able to see from this, this is like compute and data scaling trade-off. We basically have ability to see any individual metric we like on here. So anything we want from this. We're also looking at hyperparameter scale sensitivity, and we even have hyperparameters embedded to separate out environments, which is not something I've seen done before. And the idea is we're going to be able to use this to draw connections between different M's. For instance, like here we can see which environments are close to each other in embedding space, so which environments tend to have similar hyperparameters when optimized. We can see like General stability regions shared across specific numbers of environments. We can see whether the shapes and curves of cost data trade-offs look the same. We can really just learn a lot from this very quickly. And we can ask and answer questions like way, way, way faster here than we could anywhere else. Are there scaling laws in RL? They're not good. Have you ever used defer C for memory safety? You don't need memory safety, man. You don't need memory safety if your program allocates all your memory up front and then frees all the memory at the end. Like, if you're not just allocating little bits of memory everywhere, it's not a problem. Hey, Jess. Welcome. What are we doing today? I think we're going to spend some time cleaning up the dashboard here and implementing the last couple of things I want to. I'm also going to take a little break from this at some point later in the day to do another run through of the little RL tutorial to see if I can get some feedback from viewers, but I'll do that when I have more people watching. I just started stream. I have this idea in my head that I want this plot to kind of look like the night sky, at least some form of it, and have like patterns drawn between it. Why are the RL scaling laws not good? Because RL has not had billions of dollars of investment in it the way that LLM stuff has. It's kind of the same thing for the rest of RL in general. RL is also just way harder. Like, RL is and has always been the hardest subfield. Use after free on your pufferenv. I mean, you can do that, but the thing is, the free is at the end of your program anyways, so... The only thing that can happen, and I have had this happen a couple times, is if you're running a sweep, right? Because the environments have to actually correctly clean up after themselves after a sweep. So there have been a couple things with this, but like definitely memory safety is not remotely on the list of top issues that would make me consider using a dramatically less convenient approach to programming as a whole. Research on fine-tuning agents. No, E10, we kind of just, we train everything from scratch because everything trains so fast. Like, when I can train agents in seconds, we kind of don't have to care that much about fine-tuning. So I do kind of everything around here except, like, the really big model, like, pre-trained language stuff. We don't do that around here. This is much more, like, smaller models, trained per task, extremely high-performance simulation, superhuman capabilities coming out of, like, million-parameter models. That's the flavor of RL we do around here. It's a really cool problem space because it's incredibly, incredibly effective. It's almost entirely untapped, and you can do it without having to have your own H100 cluster. Ran into that with my chestnut. Yep. Yep, you can do that. That does happen. Use after free. You probably like freed observations or something. You probably tried to free like your obs buffers or something that you weren't supposed to. Do we want to stretch? Maybe we do want to stretch this, right? So we get like a uniform size plot. I could see that. We just stretch this to a unit cube. Yeah, so all this stuff here. Why do we need baseline and policy gradient method? People claim that there's high variance. Well, you need a lot more than a baseline. Like, policy gradients just with a baseline doesn't work. You actually... So RL is almost entirely dependent on the advantage function, in general. It's a very hard credit assignment problem, essentially, right? Because you're trying to push action probs in the direction of reward. So if you have a sparse reward signal, you're basically just hoping that if the reward is good, you push all those action probs up of like the whole trajectory, and then if they're bad, you push them all down. So you really don't have that much information to work off of. And then your specific question is just essentially saying like, hey, I don't even know how good the expected reward is on average, right? So at least maybe I can push stuff up if it's better than average, or push it down if it's worse than average. But that's like really, really primitive, right? There's way better stuff you can do than that. If you take a look at our advantage kernel, you'll see the calc that we use. It's generalized advantage estimation plus vtrace. And what the hell did I do here? Policy or the value function? What'd you say? That's kind of a weird way of looking at it, because the value function exists in order to help train the policy, right? It's not like which is the bottleneck. The only reason the value function exists is to help you train the policy. You don't even need to run, at least usually it's a partially shared network, but you don't even need to run the value head for inference if you don't want to. Why don't we just take the argmax of the Q value? Well, first of all, we don't have a Q value in what we're doing here. We have on-policy methods that are directly training policy and value function. And second of all, if you take argmax of Q value, you have a fully deterministic policy, so at least you're going to do some epsilon greedy thing. And then if you just do that, like, that still doesn't help you do credit assignment, right? And mechanics. 9 log 10. Q values. Q value not so good. You can sample from softmax. That's what we do in on policy, right? You're gonna make everything a lot more complicated on yourself if you're thinking of it through the lens of LLMs. Because LLMs are like very complicated things that are doing really dumb, stupid, simple RL. Whereas we're doing like relatively sophisticated RL where everything else is very simple. You're gonna get yourself confused. Hmm. What am I doing wrong here? Let me think through this properly. So we're gonna get some bounds. Do this first. This looks square. And definitely reshaped. Interesting. Ah. This actually is 0, 0, 0. Extend to 1. This does. And the camera is screwy. We'll just make the camera tar go 0.5. 0.5. Wait, what? Oh yeah, let's just do this. There we go. Now we just have to figure out the data transform, right? What's a reasonable horizon for chess? What do you mean, what's a reasonable horizon? Two-head plateaus. Is this self-play, or are you training it against a, Are you training it against, like, a fixed opponent? Self-play? Well, then it should plateau, right? Training against itself. It's a good debug thing, Jess. The one of the first things the Dota team did was they spent like at least, I think they spent a full couple of months on scripted bots for Dota, like just trying to make better scripted opponents than the built-in ones. Dota already had like scripted bots, but the built-in bots for Dota are so bad that like you can beat them as a new player who's never played a MOBA within a couple weeks of like playing against them. Elo does too is the issue. Okay, so if Elo plateaus, then there's a problem, right? Elo should not plateau. Builder port. It needs to be fast is the thing. Like literally doing one move look ahead would be enough. Like if you get something that never just one move blunders, like you're already gonna have 1,000 elo, right? If Stockfish has a low enough setting, then sure. I started playing a little bit of chess like a few weeks ago, mostly because of that project. Yeah, I think you probably would be 1,000 elo just by not blundering shit. I can't not blunder shit. I'm bad at all games, though. I'm probably below 100, 1,000. Well, you might be able to even be higher than that by just not blundering. I don't know. I'm terrible at all games. Except MMOs. It's, like, really quite irritating. That's not bad. I probably need at least, like, some sort of label on these. But I guess that when you do it this way, they are all relatively normed, right? Yeah, so they all do get relatively normed when you put them together like this. Right? Yeah. Parallel memo on the bottom. This is sweet looking. The current PufferLib implementation suffice. The one janky thing is that you have to skip every other step because it's a turn-based game. So that's kind of stupid. But, like, you should be able to get it to do something. Some stupid bug with round robin. Take a look. It's a MUN model with improvement. Are you training multiple models against each other? You shouldn't be doing that. You should do something like historical self-play. And honestly, you should at Spencer every, like, so often with some questions, because Spencer's working on similar stuff. Not in chess, though. Okay, I really like this. This is cool. How do you render a star with shaders? What do you need to do to make a shader that, like... What game is Constellation? This is not a game, my friend. Let me answer some questions. Take your bot and bootstrap. Yo, what? Hey, alien. Spencer's L1 whatever. Like it's like Lionheart with a like bunch of elite. L1 and it'll autocomplete. So mechanics. Constellation is not a game. This is the visualization for all of our RL experiments. So if you just go on puffer.ai, right? Okay, a lot of these are games, not all of them though, right? We have like driving and drones and stuff in here too. And what we've done is, at least so far for a dozen of these, we've run over 1,000 experiments per environment. And these are the aggregated results of that. So what I'm doing is I'm making a visualizer for a huge amount of experimental data. But, you know, I'm trying to jazz it up a little bit. And I got the idea for the name Constellation, so I've got it in my head that it would be really, really cool to have this, like, have the visuals in some way be reminiscent of the night sky. And I'm trying to think of, like, a nice way I can do that. So I'm, like, looking at some stars. 3D planetarium. That is awesome that this exists. 3D planetarium software. And they have stuff like this as well. Whoa, okay. That's awesome. That is really freaking cool. Land on any planet and view its 3D surface. If that's actually accurate as well, that is awesome. A lot less cool if it's just random ass, you know, generated planets. If these are real planets, though. That can't be a real planet, right? No, there's like, we don't have planets with water on them. Oh, real celestial objects. Oh, okay. So there are actually lower fidelity, but they exist. That's cool. Do we have, stars? Ah. Constellation. They're kind of just variable size points, aren't they? Like if you look at like night sky. I guess there's like this blur effect as well, right? There's like this. And obviously the background aspect of it as well. But it is mostly variably sized points. Is it real? Is what real? Digitally generate. Well, no, I'm not trying to like make a cool game, right? I'm just trying to like come up with like a cool thematic thing for some of these visuals. First of all, let me see if I go from, so if I just do, I know the spheres are slower is the thing. So this is probably way slower. But we'll see. Yeah, you see it's way slower. If I just do one of them, though, it'll be fast. This does not look cooler though, does it? It needs hmm. I think it's just I need like some sort of star shade. How old are you? 28. Should probably get some preliminary thing to play with out of Grok. Bunch of bright points with chromatic aberration. Yeah, but we're going with constellation, right? That's... I don't want seashells for this. I wonder if XOR dev has anything. Where's this thing? There's anything for inspiration here. Stellar? Literally. Dude. I love this guy. Look at this. Oh, yeah, 113 characters. I'm here like, oh man, I wonder if I can do this, and he has 113 characters. Beautiful. Wait, he doesn't have a license button on these things, does he? Whatever. I know he licenses these for like $100. I'll go send him, I'll use this, and if I can get this integrated, I'll just send him $100 or whatever. Let me make sure that he doesn't have another one. I keep telling him to add a buy button to this page. Like, he needs to just add a buy button to his shaders. Yeah, this guy is very cool. He has multiple. He even has this type. That's so funny. Well, let's go get that one. Rid of this. On Windows, I need WSL. Technically, you don't, but I highly recommend you do. I highly, highly recommend using WSL. Windows is just a bad dev environment in general and will cause you other issues. I don't even know how he has this many different things that are exactly what I want. But I think we'll just go grab his like super lightweight. And then I can probably just stick this stupid thing into Grok, right? Or I can stick rather this thing into stupid Grok. Be more accurate about that. How are... I'm not really leveraging shaders for RL. Frankly, this is just for the visuals. We do have little chunks of CUDA here and there, but... So I'm making this thing. This constellation. This is our dashboard. And I want to jazz this up a little bit so it looks cool. And the best way I can think of this is the theme is called Constellation. So I just want the points in all of these different graphs to resemble the night sky, right? To resemble stars. Just like a nice, like subtle little glow type effect, a little bit of distinction on the sizing of the points, right? And I think that we can actually make something that looks really cool. And we can actually make it less neon as a result because it'll pop more. But we can actually make something really cool here. And if I get a chance to use one of XOR's shaders in the process, awesome, right? This is the shader I found from him. I mean, these look really nice, right? Look at this. I'm sure this is considered a super basic shader, but yay. Oh, this is the one that runs live in your browser. This is the high-res version. This is not a video. This is just running live. Yeah, I'm sure YouTube compression doesn't like it, but you can go look it up, right? Here. Oops. I think you have to post the whole link, not just the chunk that got highlighted, but... Will this replace WANB for people who hyperparameter optimize a single env? It doesn't have to replace it, because it doesn't have the same... We're not doing, like, the same experiment tracking thing where you have a UI, where you can, like, go click individual experiments, and, like, you look at all the plots. I'm not doing all that. I'm just doing a single-screen dashboard, right? But the thing is, you can do a lot in this single-screen dashboard, right? Because if you just want to make plots of different variables, right? Here, let me... This thing is not perf optimized. Let me get rid of this. All right, so look. Okay, I want to look at MOBA. I want to look at cost versus, let's say I want to say look at agent steps versus score. And I want to color this by lambda. Right? There's your plot. And let's go apply the exact same thing to grid. Go to like Pong. Actually, I want to look at agent steps. Oops, I already have that there. So let's just do cost. Right? And like you can very quickly do a lot of visualization and analysis on this. I think it's still doing this. Will it work with it? Yeah, it'll work with a single env. I just did, right? I literally just did for you. Look. This is all envs. You can click a single env. So whatever envs you have loaded in, right, you'll be able to click a single env. And like here, I'm just looking at one env. And now you can compare, you know, you can do whatever plots you want. So yeah, it's meant to be just like a generally nice, useful little dashboard. It doesn't have to completely replace WANDB and stuff. And in fact, you know, if you do like one very big experiment, you probably want to have that on like a tracked dashboard, right? But if you want to do aggregate analysis, this is really nice because it's really fast, right? Like, stuff does not work this quickly on 1B at all. Yeah? Only thing I'm not sure is how we implement. I think it has to be done slightly differently for the scatter. If I run my training on a remote machine, do I need to export it CP to my machine? If I run my training, so you have a couple options, right? The stuff like Neptune or Wannabe will do it on web browser. This is an aggregate viewer, so this is not just for like one experiment. So the idea of this is you have a bunch of runs. You're gonna run like a data pre-processing script on all your experiments, and then you'll just take that file and load it into this viewer. So yeah, you'll either need to have you'll either will have to SCP it to use this visualizer, or you can set up just X forwarding, which I have actually gotten working with Puffer. Oh. This is interesting. Billboarded sprites. I would not have thought of that. Okay. Let me see if we can make this work. Yeah, but also like Macs don't really like Linux anymore these days, right? They have the new or not that new anymore, the Apple Silicon chips, which pain in the ass. I'm a third year student, welcome. How is Asahi? I've not played with it. I don't know. Let me not cover my chat with this. Welcome, Sampatil. Welcome, welcome. Want to know how to be a crack dev? Start building stuff. And read my guide on X. It's mostly going to steer you away from bad things that will waste your time. I'll bring it up real quick. I'll put this in the chat, actually. These are all of my best general recommendations for programming as well as ML. But there's some general programming and stuff in there. It's simple stuff that you really have to take to heart. It'll prevent you from wasting a lot of time. For RL specifically, there's a follow-up to that guide that also includes stuff about writing M's. Okay, so this is just going to be the billboard version, I suppose. Let's try this. Billboard. Yeah, this needs the camera. I guess this needs the camera. Points. Color, point colors. Points. Vector 3. Array. Okay, so let's just do point s. Stuff is taught in college. Yeah, you can go to the top universities in America and they'll still teach you shit wrong. Like, I went to Stanford and MIT, and I may as well say that my programming knowledge is self-taught, because that's closer to the truth than saying I learned it at university. Like, they really, really do not teach you to program. Not to say that there's not other valuable stuff there, but teaching you to be a good programmer ain't one of the things they do. What does draw a billboard do? It's gonna render like a 2D texture facing the camera in 3D. You're sort of expected to know how to code when you reach PhD level. Yeah, but the thing is, nobody fucking does. Dude, if I just see like a random indie game dev and I see like a random MIT PhD, my bet's on the indie dev being a better programmer. Like, most CS PhDs are fucking terrible programmers. It's like appalling. Literally, just go scroll through like any of the open source repos for like AI research. It's so freaking terrible. It's so bad. This is a gen texture, right? Yeah. Gen texture. And then camera. That's harsh. It's true. They really don't, though. So research people, the thing is, they know how to do science, and they get too caught up in doing science rather than solving the problem. That's the main issue. So when it comes time that the way that you have to solve the problem is by writing a lot of good code, they're just stuck and they won't do it. And they'll waste years by not doing it as well. It's a blind spot, let's say. Writing good code is hard. Well, I guess it doesn't feel that hard to me anymore. It's more so that like the way it's like completely diametrically opposed from the way that I was taught to learn to code, right? So literally, the process was be taught to code, be taught completely wrong, and then slowly over the next decade of my life understand that I was lied to and have to like relearn everything. And that's really hard to do. Yeah, that's mostly what I do, right? And it's like, hey, what happens if you just apply competent programming to a bunch of these problems that haven't been solved? Oh, look, they're solved now. Erroring on texture 2D. I don't think this will copy the full texture. Well, them some billboards. Look at that. What was taught wrong? I mean, everything. They teach you, like, object-oriented design in Java. That was my first CS course. There's almost not a single correct thing in that entire... Like, the only thing that they get right about that is the nuts and bolts of this is a condition statement, this is a for loop. The way that they teach you to apply everything, literally everything, is fundamentally wrong. If I made a syllabus for Intro to Programming, what would it look like? Probably here's some Python. We're going to play around with some basic stuff that's not going to exceed 200 to 300 lines of code for a few weeks. And builds a couple cool things to get you interested and see that you can make stuff. And then you're going to learn lower level dev. And you're at least going to be shown low level programming much earlier and in a way that is not painful. And you're certainly not going to be given like an assignment where you have to fill in the blanks of like a massive chunk of starter code. You're going to be made like you're going to write entire programs yourself from scratch. The idea. Okay, now we got our confetti. Look at this. We got confetti, right? This is kind of cool. Web dev and TypeScript. Go jam some C. If you know C++ decent, just come build some cool... Like, literally just come do some stuff with Puffer, right? I mean, I stream all this dev. We have a ton of people doing this stuff now. It shows you a cool thing with AI, but it's basically just low-level game programming, right? You could build stuff like this, right? Biz GPU or CPU based. It's hooked into PufferLib, which has OpenGL as a backend. So, Sampiel, if you know enough to write basic games, like, come look at the way that we do stuff in Puffer. Because this stuff actually, like, this is now AI playing this in your browser, right? This is a neural net playing this in your browser. So if you're looking for a cool way to learn some lower level dev and to get better as a programmer, this is a fun way to do it. And I have, if you read some of my articles on X, I have some pretty comprehensive guides. And then we have like 2,000 people in the Discord, some of whom are quite helpful. No, the billboards don't have the glow effect yet. I'm trying to figure out now why the shader is not doing anything. Failed to open text file. There you go, that's why. Yeah, no worries. And start the repo on GitHub. It's free and it helps me out a ton. In fact, I'm actually, Sampiel, I'm gonna probably, once I finish this glow effect, and once we have a few more people watching, because usually my streams have more people in like the mid-afternoon, I'm gonna do a quick tutorial, like just a walkthrough of one of the starter pieces of code for Puffer, because I'm doing a tutorial for an academic lab tomorrow, and this is going to serve as practice, plus a way for me to get feedback from a couple of my viewers. Honestly, just literally the only thing is it's just a matter of time. If you just like stick around and listen. The thing is you're starting with a fairly hard project. Like chess is a very hard project to start with. Most of the people around here I've had start with much simpler stuff. Like even Spencer. So Spencer's first environment I believe was Triple Triad. So Spencer's now like doing stuff with me professionally for Puffer, right? And he came in with zero AI experience, or zero RL experience at least. And this was his first environment, and let me tell you, the code was awful. He just got a lot better very quickly. So yeah, this was his first environment. It's like a port of the Final Fantasy card game. Okay, so what's happening with this? Failed to open text file. Warning, file IO. Failed to open text file. Well, yeah, because it's not a file name, dummy. It should be VS Code, FS Code. Is this just the... Yeah, this is a frag shader, right? Is there a get default shader? Hmm. Love it. I would like a tutorial on low-level parts of Puffer. I'm gonna go through the target environment. Oh, that's a much broader thing, E10. I can go through. Actually, I might go through bits of that because I'm gonna get questions from the lab. So yeah, you know what? Let's say that when we have a few more people on in a couple hours, then I'll do that. You mentioned skipping steps. Why not flip the board? That's worse. But just isn't that's worse because then it's like, what's the reward it's optimizing? If it's gonna get a reward of 1, whichever side wins, right? Then there's nothing to optimize because it'll get it'll do that either way. You can't. That's like just having one agent. You're having like one agent playing against itself, and like the reward is, I guess if it's 1 for winning, then it's just gonna find it's gonna find Scholar's Mate. Actually, is what would happen. Like you'll literally just train an agent, like a Scholar's Mating agent. Yeah. Well, hang on. I can just do this, can't I? Am I just being stupid? I can just do. Well, that's doing something. Not what we want, but that's kind of cool looking. Can you timestamp the stream? I suppose so, yeah. Tic-tac-toe for self-play. Mind when you mentioned. Use Vim motions. Is that a thing other than HJKL? Oh yeah, that's just HJKL. Yeah, of course. And then jumps. Yeah. I use a very basic set of them, yeah. Okay, so this is like putting stars across the billboards. It's very weird. And compose them. I don't know, I just do this. I do stuff like this all the time, right? I mostly just scroll around like this, and then I just like jump to approximate line numbers, or like to file defs or something, right? Or to calls. Pretty quick. So this produced something utterly stupid, right? Is what I'm guessing. Yeah, because this is just applying the same shader. Yeah, this is just like applying the same shader. Yeah, this basically put the original shader onto this surface, which was not what we wanted. Oh, you know what we get, actually? So, do we get the position of it or not really? You get the text chord. You get the location of the, You get the location, don't you? I'm trying to think what we need for this. You kind of need the distance to the center. I have to actually think about how to do this. What's PufferLib's next project? Well, we're gonna have the largest scale. We're gonna have the largest scale, nicest, most polished visualizations in the field. So that's a pretty darn good one, I'd say. I have to finish running all the experiments. And then there's a whole bunch of perf optimization. I think we can make Puffer several times faster. I think Puffer 4 is mostly going to be like just pure speed, and then basically leveraging the pure speed to move more of RL. We're going to move the RL loop towards the sweep region, if that makes sense. So right now, where the unit of an experiment in RL is typically it's just a training run, we're going to move the unit of compute up to a sweep. I'll make it faster. We're going to do some compile shenanigans. That'll probably be this coming weekend. We have some shenanigans to deal with. Some low-level dev. Some other things. I'm trying to think how I would do this correctly. So because right now it's just getting the positions of all of the billboards, right? It's going to be more than compile the neural net. It's going to be compiling the training loop. We're also going to do some like CUDA environment shenanigans. You'll see, it'll be fun. I'll be streaming it live probably this weekend. Most likely this coming Saturday. Go. What's this I? Yeah, it just wrote this garbage shader. Let me go back to XOR's original. Let me see how we did this. Oh, but his is gonna be... He's gonna have like some thresholded thing, isn't he? I... What is FC? XY? Wait. Times pi. I think that it's just completely backwards, right? Because... Yeah, it's completely wrong. Like the... I mean, Grok stupid thing is, right? Because this is... This is the number of points, I guess. Alright, I think I'm on my own. These models are stupid. I mean, that's kind of expected. I'm having difficulty figuring out how I do this so that it's like... How do you make it so that the shader applies to a circle on the billboard? C dot. It's probably in here, isn't it? 2E1. The problem is I don't know this area remotely well enough. And so I don't... Honestly, this context is not even helpful. Simple fragment. It has to get applied uniformly to each billboard though, right? Unless I load it in. Well, wait, maybe I don't need to have it... Maybe I don't need these billboard sprites at all, right? Yeah, I don't need the billboard sprites at all. Here, this is what we'll do. Yeah, exactly, 10. Let me, I think that the billboard thing was dumb. This is what we're gonna do. Like, can I copy paste from here? Oh, I didn't realize I can copy paste from this. Lol. Oh, I can only kind of copy paste from this, I see. Oh, it's on the other buffer. Okay. What, no, wait, what? Oh, that's so weird. That's weird. Yeah. Do this. I think this is the correct approach. You just load the entire data into a vertex array. Yes, it's a little annoying because it'll mess up the camera stuff. What? Oh, it's just stuck. I'll give it a minute. It's gonna be something like load points into buffer. I'm probably gonna end up with two shaders, right? I'm gonna end up with a 2D shader and a 3D shader. provided I don't do the math myself. Whoa, what the heck? SSBO. Yeah, that's too much garbage, my guy. Yeah, we don't need to do this much crap in the shader. Can you not load in a vec4 array? Totally should be able to load this in. This need 3D. Ah, I see. RL get matrix projection. I see. So this is fine. And then this is on CPU, right? Yeah. be quick. Okay, so we get this. Reprocess everything. What the heck? Where do I think we will be with RL for law enforcement? Literally nowhere. The only thing it's potentially going to get into relatively soon is drone control. And that's not really law enforcement as much as it is military operations. Okay, so this is much more reasonable. You end up with a very short shader. And the problem here, right, is going to be that you actually want to do this whole thing in one big call, right? Or no? No, it doesn't have to be in one big call, right? I think I can literally just do it like this, and it works. Let me see. I'm gonna have to be a little careful with this, but I think that I can literally just do this. So environments? I don't know, dude. I don't currently do any work with defense. We do have a few things that we've done with like drone demos, but we have not like spun that into anything for military application. The possibility of a completely not really. I mean, my optimistic hope for that is that we just make is that human infantry become essentially useless in battle, and as a result of that, war just becomes two companies throwing money at each other until they break all of each other's toys, and then and then continuing a war any further would just immediately be considered an atrocity, right, and universally condemned. So I think it's possible that you actually make the war less lethal, not more lethal. Of course, we'd have to see what actually happens, but it's not like clear-cut dystopian hellscape. And it's also not the most interesting thing for RL either. Any rich guy can get an army. A small one. I mean, that's like Kind of. To be fair, you can do that already anyways, right? It kind of doesn't change that much. Um, is it called matrix multiply? Matrix multiply. Supposed to be a matrix vector though, isn't it? Matrix. Yeah, I don't think this is being done correctly. I think what we should do then, here, this is what we'll do. Yeah, let's go apply this to plot 2 first. So the idea is going to be that we do the easier 2D function, and then it should be identical for 3D, except you have to project the data correctly first. Oops. What? All right. I'm going to take a few minutes, do a couple sets, use the restroom, grab a cup of coffee, and we will continue on this. Okay. That looks better, right? Yeah, that looks good. So, here, let me see if I can get something from this. Oh, and let me just double check one small thing with the email. I just want to make sure I didn't miss a message. And nope, I have not. Whew. Alright, so what we're gonna do... Oops. Did it change the sig? Nope, didn't change the sig, so perfect. And vertex shader. Slightly different. I think this one's literally the same. This one's the same. We do need the shader. So what we're gonna do, best in mode axis. Ignore this, like so. We're gonna put this on plot 2. Yeah, let's say plot 2. Like this. And like this. Right? We can get rid of this crap. The point shader. This will just be shader. Oh. Hmm. Sure. Patient uniform. It needs shader ID. That shader value. I don't know why it's done all this mess. Why you don't use LLMs, they're bad. But I'm happy to spend some time on this today. Index. Bulk index. Loc index. Oh my god. Bit loc size. Oh, that's why it's done. Another news, dog bites man, yes. The heck is this vertex? Yeah. Does anybody have example code? Is there like Raylib example code for this? Would be much more helpful than the LLM just making shit up that doesn't work. I do not like LLMs, MIM. Isn't it just a texture? I would think it would just be a texture, no? Chord. Circular points. I see. I actually don't understand how this makes sense. Does anybody know how this works? So it says that you can draw GL points, and then in the shader it looks like you're getting the distance from the points in order to do attenuation. But how does this apply to all points, right? Like, this doesn't say what to do. I don't think that this says what to do, right? When you have a bunch of points, does it? Uh, the hell? Oh, so it just goes off and does whatever then. Cool. Isn't this, like, utterly depressing, actually, here? Like, this is just stupid. Why am I doing this? Models are shit. PufferLib, shader examples. It's like every single time I try to use an LLM for literally anything, I regret it. Is there anything that's, like, close? Text. But these are all constants. I need something that's drawing... Yeah, but which is always, it just never does anything right. So the thing I don't understand here, right, like... I don't understand how you draw, like, different points like this. By George Style Docs. I mean, not really. At least those are correct. That, like, garbage LM output isn't even that. But the thing is, I don't have... The thing is, I don't have an example anywhere, right, where I'm doing something similar. I need something that handles it's like from multiple points expanding out. I'm trying to think how we do this. I guess I can at least put this thing in. Let me see if I can at least use it to figure out what the hell this is even trying to do. I pretty much just want, instead of rendering like each of these points as a sphere or a cube with a separate call, I want to make a shader that handles all of them. And then because I have it as a shader, I can actually have it be like each of the points can basically render like a little star like this. And it's going to look really freaking cool. What are the points? Yeah, the plotted points are going to be the points, right? Oh, cool. And you can enable blending. I see. So it's not that far off. Their RLGL cheat sheet. No, there's no RLGL. Damn it. Yeah, there's no such thing as vertex attribute pointer. I don't even know how it is that there's still discussion going on under this. I made this random repost and it got 250,000 views. He just says read the textbook. Funny. Alright, to be fair, it's a really long and dense textbook, okay? This is gonna look really cool when this is done. This gives you a totally different type of thing. Can anybody actually explain why we have, like, GLSL, and we have, like, compute shaders, and then we have CUDA? Like, why do we have a million different things to just do the same thing, which is do parallel ops on GPU? Like, I guess technically you could write this type of a thing in CUDA, right? It would just be like, you do the same ops parallel to a buffer, and then you splat the whole thing to the screen. Alright, let me try something. I'll try this again. Am I right? There's no, like... Yeah, there's no RL vertex attribute on there. Okay. Load. Const void star. Call to undeclared GL draw arrays. I know what I'm gonna do. Is it all to set vertex attribute? It is, right? It's supposed to, what's it supposed to take? Int offset. Supposed to take int stride. Yeah, the only reason I'm doing this here at the moment is because I'm kind of blind in this space. I'm not really used to graphics programming like this. At least, like, lower level graphics programming. I probably should just take some time to, like, let myself go learn stuff like this. I'd probably have a fun time doing it as well. The thing is, I very rarely take time to go learn things that are not at least, like, tangentially related to stuff I'm doing immediately. I think it's a lot more likely that I go deeper into CUDA. In fact, that's probably going to be something I do quite soon, is try to do CUDA environment wrappers. I think that I could make it so that you could run puffer envs in CUDA as is. Okay, obviously we need to include OpenGL. And then this is a little sketchy, but we're gonna see. And I'm not just gonna keep blindly copy pasting shit in here. If this is not working, we're gonna go a little deeper. Okay, so load shader code. This one I know how to fix. This is just load shader. This is from memory. Load shader from memory. CUDA is bad for general ops. It is. The point is not going to be to make the end faster in CUDA, though. D10. The point is going to be to make it compile end to end. You will see. Uh, okay, so I need to link G. I think I need to link. I need to link RayLib, right? Or no, I need to link. It should be installed. Can I just do LGL? LGL. I just do this. Do you just need... Do you need all of them, or do you just need LGL? Oh, there we go. Whoa. Oh, this is the old billboard thing. We have any errors? Not have any errors. But nothing shows up. Wait, draw arrays, GL points. We have valid count. And then this one, okay, this gets stored. So now we have vertices, right? And then these get loaded into buffer. So we should just be able to... Okay, so these coordinates are just wrong, right? Like, these coordinates are totally wrong. Let me see if it did some weird thing. Because, yeah, this is supposed to be rel chords. Okay, so this is what I have here, right? Let me see where this went wrong. So this is the same from before. I have the same. Oh, there's no filter. Cool. So 16,128, right? $960 and X. So X is getting logged. Okay. And do we have Y? Log Y is false. So our first chord, oops, we have our X, which is, where's our log X? And we have Y. We'll focus on X to start. Min and X max. So we're going to do like this. X min. X minus 2 times args. All right, that's actually pretty close. And then it's going to be plus X margin. So yeah, this is what we get. That's not correct, though. So why do we get this? So because this should be This is supposed to be between 0 and 1. Okay, because this is bigger than x max, right? Why the heck is this bigger than x max? This is cost? Well, cost can't possibly have... Why is this getting logged? Am I doing it twice? Oh, I'm probably doing it twice, right? Yeah. Just go double check. So for plot 2... Yeah, look at this. I'm doing it twice for some reason. I don't know how that was supposed to work out for me, but not well, apparently. Okay, this is a much more reasonable xi. Yi... And now this is something that should show up on the screen, right? Yeah, this is something that should show up on the screen. Now that we have something where we expect something to show up on the screen, why does nothing show up on the screen? I have one env, right? I wonder, is this supposed to be in pixels? Location, position. I wonder if this is supposed to be in pixels or if this is supposed to be 0 to 1. Was just gonna spit code at me. do anything. Alright, let's see if this is loading the shader. Should say program, okay, fragment shader loaded. Okay, it loaded successfully, right? Wait, what's this? Oh, this is the GUI layout thing. Hmm. Draw vertex array. Can we not do it from this? I think we can do it from this. On one hand, it's kind of silly for me to be sitting here all day trying to make my plots look like they got stars in them. On the other hand, I'm learning a few things about shaders, which are kind of nice. And this is going to be really cool when it works. And I kind of feel like doing it. Oh, this is cool. Lovely, doesn't exist. You'll draw triangles, I see, so that's bad. So is it just not flushing? Yes, yeah, there's still nothing. Oh, but we didn't do, we did not apply this fix yet, right? Still not seeing anything. Debug link, okay. Yeah, this looks fine. Oh, you know, there actually are several things screwy here, aren't there? Yeah, I have an idea. I know what we're gonna do. We're gonna get a minimal example of this, and then we're gonna port it into this code. That's what we'll do. Because I think that if this thing should at least be able to get a minimal like standalone example. Yep. It's spitting code at me again. See if I can get this. And what we'll do is we'll just go from here. We'll just do debug. This could just be like some dumb shader loading jank anyways, right? If I can get a minimal example, I'm sure I can get it ported into this. And honestly, this is usually the only hard thing with the shader is getting it to do anything at all. From there, it's just gotta be... It's integrating it with this thing, loading the data from the plots in, and then the only thing I gotta do for the 3D one is the camera projection, which is just a single map mul. Right? That shouldn't be bad. I mean, I would honestly rather than having this stupid LM in here, I'd way rather... Do you think I can get this? Actually, can I get this example from an old branch? It should still be in there somewhere, no? Ooh, look at this. Here's something. Resource shaders. Resource shaders. Where's my point particle? I think I found a real example code that's not just LLM garbage, which is what I wanted the whole time. So if I can get this working, then I can do it. It's gonna take some kind of gross OpenGL, but it's not that much. Resource shaders. Yes. His code is so clean. Raisons? Oh yeah, LLM code is always dog shit. Yeah, Raison's great. Does Precision BF16 work well? Nope. Because it's nerfed on consumer cards anyways. I actually am going to be messing around with, I got some ideas for how to leverage BF16 though, despite that, and I'm going to probably be doing that on Saturday. If you want to tune into that stream. If this works after all this messing around with LLMs, I will feel stupid once again for attempting to LLM literally anything. When I can just go try to find example code. I didn't realize that there was any out there, to be fair. It was like in a niche branch of this. Glad. Glad. What's glad? So this is, what even is this? Oh wait, there is no GLAD, right? GLAD. Damn it, Major. There's gotta just be a link arc for this, no? Oh, 3. Force. I can just drop these in, can't I? Yeah, I can just include these. So hang on. Ooh, look at this. I don't know, it's some loader thing. But look at this. Here's the particle system. That's pretty good. Okay. That's pretty cool. GL. Okay, so this gets... Oh, this actually even does the matrix transform for me. Lovely. Right? So all I have to do is I have to have this modified so it can take an array of colors, right? Because where's it getting the points from? Yeah. Adapt this. Try the example. That's the only other thing I don't know how to do. This gets kind of esoteric at this point, right? Because we're kind of halfway between OpenGL land and RayLib land. All right, let's see if this does it. Protocol. Even this doesn't work. Let's see. And the points are all black. Lovely. This takes vertex color. How can the policy loss be negative? I'd have to look at the math. See the tutorial. Well, there's more to it than that, Jess. So there are a couple more features to add to Constellation. There's some cleanup. Then we have to actually like get all the experiments into it. So there's more experiment side work. And then there's the performance work. So in my mind, they're kind of like 3 parts to the next update. There's the performance side work. There's the running of a huge numbers of experiments and getting everything correct and getting all the data. And then there's this visualizer. So this visualizer dashboard is about a third of a major update. Another third is just like getting all the environments nicely ready and having all the experiments run in an easy to reproduce way. And the third component is the perf optim. All right, we will try this one more time, and then I will delete all of this, and I will go back to doing it myself. If this one does not work, I go back, I just close the LLM tab, and I try to do it myself. Because LM's stupid, and kind of all there is to it. Oh, okay, yay. We get lucky for once. So, that's not bad. Solid configurations. It's not done beyond waiting for experiments, because we'll have another dozen M's for which to do it. There's going to be analysis on that as well, Jess. Okay, so this does work. Okay, so this does work. Guys, like... It's funny he did the grok, like the grok effects. I hope he got a lot of business from that. Pretty much, Jess. I really try not to do that very much, but like when I get into an area for where I have very little knowledge and there's very little documentation, right? It's kind of just tough. Yeah, so what happens when you do that, Jess, is it gives you garbage. If I can write the pseudocode, like I can just write well, the problem is it's like I only do this when I have so little familiarity with the API that I can't even do that. Right? Like if it's just a matter of me looking up the function names, I'll just be like, "Hey, what's this function called?" and I'll write the damn code. I mean, this is like graphics programming, which is something I have very little experience with. But then it's like it's halfway between just OpenGL and also hooking into PufferLib, and there's like several other things going on here as well. Okay, so this works, but they're super faded. Yeah, they're like super faded. Why are they that faded? 0.5. What the hell? Why is alpha that low? Obfuscate a tuple. Discrete. Does Puffer know how to encode? No, you shouldn't make your space a tuple. Puffer actually does have a ton of space, like automatic space handling stuff, but it's faster to just do boxes and handle it manually, right? Okay, so this is dog shit, is what this is. Alright, that's why you don't use LMs. See if I can figure it out. Here's the original. Here's this insane piece of very clever code. Hey, hey, that FBR, hey, fiber. I'm trying to get this into this. What is this op doing? Length of fract. Yeah, but how do you get this? fc.xy. Doesn't look anywhere near like the original does. Does anybody know what this is doing? I can't like... Yeah, so FBR, I want to make the points in the plot look like these. Well, it wasn't able to implement it before, so no, doesn't bode well. What the hell does that have to do with anything, FBR? This is a shader. Wait, can't I just do this directly? I totally can, right? I literally should be able to... I mean, I'm just being dumb about it because I don't know what I'm doing. Here, wait. PufferLib shader support. You end up having to get kind of more OpenGL to do this, Fiber, because you're doing this off of a point array. Like, you've got a big array of points. This is gonna look really frickin' cool if we can get it, though. Yeah. If I can just get this to implement the shader, I can get it ported, I believe, into Raylib. Like, I just need this base thing, and I can figure out how to port it. I don't know enough of the OpenGL, right, otherwise, but I think that I can get this to run. I can basically just refactor my plot functions a little bit, and I should be able to get this to work there. And then we'll just add, like, the current one will just be the fallback, basically. Way better job at explaining it. Well, this is not what it is. Is it? It's wrong, isn't it? It doesn't know what it is. See if I can, let's see if this works. and completely screws it. Alright, I think what I'm gonna do is I'm just gonna port it as is, right? I'll just like port this as is, and then I'll see if I can get some help on how to get the shader into this. Well, if it doesn't understand it, then it can't be explaining it correctly, right? Okay, here's what I'll do. Here's what I'll do, folks. I'm gonna start, we're gonna leverage the chat a little bit. We're gonna make this audience participation. Here is the current shader code. It's going into the chat. That's gonna kill all my new lines, isn't it? Well, it's okay. It's only a few lines. There's the code. If you can get XOR shader, it's called star here. Stars. If you can get this into to work in this, that'd be awesome. I am going to use the restroom real quick, grab a coffee, do a couple sets, and then I'm going to start porting the current shader into the dashboard. And then the idea is hopefully it's just going to be a change to the fragment shader to make it actually look good. But I got to start in the integration so that we actually get it into the dashboard today. I will be back. Cable curls feel good. Cuts off half the message. My bad. Let me do that. All right, I put this on the stream. Let me check one message and then I will start on the port. And we'll try to like get a couple, however long it takes me, an hour or two, hopefully, to do this. All right. Here's the plan. Next couple hours, we get this ported in. You all see if you can figure out how to do this with that shader. And then we will put them together. That is the goal. on an Envol's training. The Twitter link to the 3. You just want to give it the effect that it's in the... Yeah, exactly. So I got it doing this, which is like okay, but the one in the tweet looks way better. So I basically just want to port XOR's shader, his point shader, to this, and I'm going to get it into Constellation, right? So it's going to be like that style of point is going to be what we use for our graph. Sent you a snippet. It's like... It's better, but they're dark. It's like they're dark. I'll keep it. It's better, but it's not the effect from before. Well, it's not just tweak some numbers, right? Like, look, do this. He literally has this as a demo online. Right? Look how good this looks. Here, like try this in development, right? Like this looks really good by comparison. Link the tweet. He has a variant on Shader Toy as well. There. Oh, better. The outside of the sphere is black. The points have like this black border around them instead of attenuating properly. Progress, though. Do you open source these projects? My guy, all this is open source. Everything here on puffer.ai, including all the RL, the training, the models, like literally everything's open source right here. Heck, you can even demo them in your browser. And the demos are open source as well. These are agents playing the game in your browser. Everything running locally. Welcome to PufferLib. Was getting started on RL? Well then, believe it or not, I have the exact thing for you. Here is all the information that I've put out to help all the people in Puffer to get into this space without going mad with all the crazy stuff involved with RL. That guide has everything. And it's quite light on the math. It's something like this, right? Do we get rid of this crap? Oops. Whoa! Okay. Welcome, Boxen. I've had a go. I will check that in one moment. Let me make sure I'm loading the correct thing. What happened? Come on. Dude, what the hell? Why does it only work when you jiggle? That's like bizarro, no? There it goes. Let's see what you've put in the Discord for me. I think yours is better. It's just too... Hang on. Where the heck is this thing using time? Where is this using time? Am I dumb? Is this not using time? Is it just the vertex shader? Oh, okay. So, let's compare shaders now. Let's compare. This one does not run. Yeah, this one does not run. Because you only posted this chunk of it. Try this. Okay, this one does not work because... Oh wait, does this not work? It's not handling these overlaps correctly. Why does this have like a little box around it? The other one doesn't have a little box around it, right? Let me see. Yeah, the other one doesn't have a box around it. But this is like muted. This one is muted for some reason. It's the bloom. Currently mechanics, yours is maybe better, but it's got this error with the boxes. I'm gonna let you guys play with your shaders for a few minutes while I keep integrating this. Declared identifier particles. Okay, we have new versions. The current candidate is this. The latest from mechanics is this. Nope. So mechanics, there's however you're attenuating this, there is a ring of black around each point. You can very clearly see it where they overlap. In this shader, there is not a ring of black. I'm fairly certain. At least. There actually might be, to be fair. It's less noticeable. You can both figure that out. I'm leveraging the open source community. We're crowdsourcing the shader. Try version before this. It might be I have to screw with the blend mode as well. That's even worse, man. That's got a box around it. So the second version, you gave me, the second version draws a circle around it in black, and the first version draws a box. Ooh, FBR has gotten me a new version as well. This one does not draw anything. So I'm going to have to say that one does not win. Your new one does not draw anything. Missing. Oh, okay, I just goobered it. Never mind. Wait, what? Where is it missing a close? Am I just not seeing it, man? No, it says it loaded. Are you sure? It doesn't look like, it doesn't look like it, man. And keep going on that for a second while I finish this. Yeah. I try not to goober stuff that bad. You know? Particles? Wait, does he literally have a function for this? Oh. Yeah, okay, Rayson's just the best. That's just, like, absurd. He just has everything thought of. Should I be able to run this fine on Omarchi? I do not see why not. I was able to train but not render. What error did you get rendering? Were you doing it in a Docker? You might have to set some stuff up if you're trying to render in a Docker. It would be, if it's not rendering on your base system, like you don't have OpenGL set up or some weird thing. Like you're missing drivers. Give me a sec, mechanics, let me fix this, and then I'll go do another pass on your stuff. So if you're using Docker, you need to have pass-through. Let me find it. What the heck is it? There's like some Docker thing you have to do. Like this display, probably. X11. I would say go get Xeyes to run. Go get like standard Xeyes to run, and then it should work. Yeah. There's stuff in the Discord on this. That's a Docker thing, not a Puffer thing, most likely. Ooh. Why do you not render? Oh, there are points. They're just in the wrong spot. Let me fix this, and then I will, I'll go through the shaders again. Trying to get 3D. Get world to screen. Hmm. With height? Oh. So can I pass EX to this? $960. Weird. Let me figure this out, mechanics, and we'll get there. I had to figure out why it's not rendering. These all look reasonable. Yeah, so this is directly in green chords. Should be fine. Hmm. I do not know what's wrong here. Oh. Okay, cool. Lol. Lol. What are your thoughts about Jax? One moment, sir. Ah. We got this for Jax right here. That's what we do. Look, Jax is just bad, and you should feel bad for liking it, okay? That's all there is to it. If you'd like, there's some profiles. There's some profile tests in the Puffer repo. So, if you want to see if you can make Jax like way faster than PyTorch or something, be my guest. But so far, it's not faster, and it's just worse. Yeah, we gotta fix some NAND bullshit. Fiber. What about M's implemented in Jax? Even worse! Completely stupid! Literally no reason to do that, ever. Literally learn to write anything that isn't Python. It's not even that good of a language. You want your M to run on the GPU, write some CUDA. It's not hard. Hell, I'll probably be doing it over the weekend on stream. Alright, mechanics. What you got for me? Your latest version. Don't need to recompile, it's just a shader. Alright, that explodes. So... Oh, because I forgot the version tag, right? Okay, this is black. This is explodey. Because it added a float time for some dumb reason. This has the black. This is the black circles version. Could you explain what these 4 screens are showing? Kind of, but it's not exactly done yet. So we got t-SNE of hyperparameter embeddings. We've got stable ranges of hyperparameters. So we can do like above 0.9 perf. Right? We can do like under 100 cost. And then this is just like a scatter of anything you like. Right? So this is all your like 2D plots. And then we've got 3D scatter of all the data. And you can filter this as well. Hell yeah. Fucking ace. Yeah, stable ranges, man. All local. I'm gonna give you a binary file and you're gonna run this thing local or on your browser. Because it's all C. It's going on the Puffer website. You load like 1 or 2 megs, and then you just have this. Who needs JavaScript? Early for Christmas? It's probably not going to be out until Christmas, I'm going to be honest with you, for like Puffer 4. Because this dashboard is about 1/3 of Puffer 4. When it's fully done with all the bells and whistles, this dashboard is going to be 1/3 of Puffer 4. Stable range is always contiguous? No. Yeah, no. Because it's overlaying all the different environments worth of mins and maxes. What do I want for Christmas, man? I want my freaking shoulder to work again so I can get my, like, 165 overhead press back. That'd be awesome. The other 2/3 will be developed right here on livestream. One of them is going to be getting all the data for this plot, like all the experiments, and releasing the full data set of experiments along with the dashboard. And the third one is going to be some pretty intensive perf optimization that we will be starting probably this Saturday all day on stream. Oh yeah. Hey guys, we have a good number of people watching at the moment, so I'm going to leave this up to hang on, let me mute my music. I'm going to leave this up to community vote here. So I can either continue working on this right now for the next 2 hours until I get dinner, or I can take a 30-minute-ish, 20 to 30-minute break right now, and I can do a quick tutorial session going through the target code, which is like the simple tutorial multi-agent environment in PufferLib. And the reason I would do this is because I have to give a presentation tomorrow to an academic lab where I go over this, and I could use you all as guinea pigs and give you a little tutorial in the process. Do we want to keep on this or take a quick break? What happened to the shoulder? Well, what happened was I had some contractors outside that right when I went to go lift some heavy weights, they were like looking in my window like this and threw me off. And I went with a 45, which isn't even that heavy, but a 45 at an angle like that. Was it 45? Might have been a 60, I don't freaking know. It was some weight. And I torqued my shoulder, and it's been 3 months and the damn thing refuses to heal. Alright, we'll do a quick presentation. I'm in a good mood. Because this shit is awesome. So we'll take a quick break, do this, and then I will be expecting shaders from you both. No, it was pretty blondes? Yeah, don't break my shoulders that way, though. I don't like pull my shoulders with that. If they were 60s, then I think both of them together would be lighter, or would be heavier, right, than one of those. 45s? I can't do that with 2 hands. No, you totally can. Kathy Woo's lab, we've got a little collab with them. I really haven't done enough for them, because I promised them I would help them with some stuff, and I've given them a few small things here and there, but I'd like to get them, like all the labs that are still doing cool RL, I'd like to be assisting more. I'm just one guy, I got limited time, you know? Okay. So. Quick tutorial. We need to commit this in order for that to work, don't we? Yes, we need to commit this in order for this to work. Status. Let me commit all my stuff up. So startup, yes. Where the heck is it? Is there another thing? Okay, so here's going to be the tutorial. Dot no build. Okay. This is the environment that we're going to do the quick tutorial on. This is the simplest possible multi-agent environment. You have puffers. Puffers eat stars. Why do puffers eat stars? They eat stars to remind you to star PufferLib on GitHub. It's free. All my work is open source. It helps me out a ton. But these puffers are not very good at getting stars, which is very unfortunate because PufferLib needs lots of stars. So how do we make the puffers get more stars? Well, what happens if we just run puffer train on puffer target, and we just sit here and I stall for about, I don't know, 2 or 3 sentences worth of speech, because that's all the time that it's going to take to run training on this for 100 million steps. And there you go, that's 40 mil, it's about halfway done. You're watching here this little local dashboard with losses and hardware utilization, and then there's this episode length performance metric, which should be going down. This one's not going down as much as it should be, but it'll still be a decent enough policy. I probably didn't run my setup fully correct. We'll add load model path. Latest. And still decent policy, right? Puffers eat stars. So that's 100 million steps of training, which normally would be something that labs would have to run overnight and like break the bank for some fancy GPUs. I just ran this on my desktop in less than 30 seconds. So how does this work? Well, it's pretty simple. You just have to write literally anything but Python. Let's show you how you make a new env in PufferLib. Because this target environment took me maybe 3 or 4 hours to make and document total back when I did it. Environment is called target. You'll see that there are some files in here. We have a binding file, we have a .c, we have a .h, we have a .py. Let's look at the .py first so you get something familiar. This is about 1 screen worth of code. There's no actual logic in here. There's just some inits. You set up your space shapes. This is pretty standard. Gymnasium, petting zoo, any RL library of your choice will have this. We define them in terms of single obs or single action spaces, which is per agent. We set a couple of required properties. And then here's our init in which we, in a loop, we make num-m's copies of the C environment. And I will get to this syntax in just a moment, but first, the rest of this is just wrapper around reset, wrapper around step. This is calling logging to add stuff into the infos, and then a wrapper is here, and the thing at the bottom is just a performance test, where I run this in a loop for 10 seconds and see how many steps it can take. How many steps can it take? We're going to run this perf test for 10 seconds. And target runs at a grand total on one singular core of 34 million, 35 million steps per second. Not bad. Try doing that in Python. So here's the magic behind that. This is a vector format by default, meaning that the tensors here, the obs that are returned, are already going to be aggregated across multiple agents and environments. These are contained inside of this buff object here that you can pass. If you give it a buff equals none, it'll make its own buffers. But when I run this with multiprocessing, buffers get passed in, and the environment knows how to populate these buffers. All this super init does is set self.observations equals buff.observations, self.actions equals buff.actions, etc., etc. And what you do here is you're going to take slices of the buffer. So here, if there are, let's see, 8 agents per environment, then this observation is taking row 0. So 0 times num agents is 0, up to I plus 1 times num agents is 8, rows 0 through 8 of the observations tensor. Same for all the other ones. You also can pass other params like this. These buffers are actually aggregated across all the different cores that we're going to use, and they are put into shared memory, meaning that this environment here is going to compute its observations in the C code directly into shared memory. That means there are 0 redundant copies required when you go to use this data on the main thread. That is how Puffer is so fast. It has no overhead, no redundant copies, no bullshit. All right, so how do we actually make our M's work in C like this nicely? Well, first of all, Puffer comes with a nice little utility to save you some time. It's called this binding file format with this env-binding.h. So when you want to define a new environment, you need a little bit of glue that makes it work with Python. This is that glue. This is including the .h file, which has all the logic for your environment. You tell it the name of your environment. You include our binding file. This binding file is what lets us run a loop over many copies of your environment and manage holding multiple copies of your environment for you, aggregating logs and stuff like that. You can read this file if you like. It's 600 to 800 lines. It has Python API garbage in it, but if you can squint a little bit, it's not that complicated. Two things that you're going to want to do in here. One is you're going to want to init any parameters that you are requiring. So in this case, you would pass in the width and the height of the environment, as well as the number of agents and the number of stars, or goals. We also can call methods directly from the .h file. So we can call this init function in particular, which handles our memory allocations. Additionally, we have to tell the environment what data we want to take out of it for logs. You can do that like this. And now there's only one other file required, which is the actual meat and potatoes, the logic. This whole file is 233 lines, including the rendering. It is nicely commented, but because I am here, I'm going to do the job of the comments for you. Whatever standard stuff you want to include, and then we use PufferLib for rendering. The way to think of this is that there are a few required structures in here that PufferLib expects and is going to look for, and then other than that, you just write what the fuck you want. You write arbitrary logic. It's not JAX where you have to write everything as JAX. It's not like some framework where you have to write everything as a framework op. You just write arbitrary code, and C is fast, so your environment is fast. This log struct is required. This tells you what data you're going to take out of the environment and send to Wanbi or Neptune or whatever plots you want. This variable here is very important. It tells you how many logs have currently been accumulated. It is the last element of the struct. Do not forget it. It is a float. Everything in the struct is a float. Do not forget this. It will bite you. C is not very friendly when you do things wrong. But we have lots of guardrails for you. I suggest including these sorts of metrics: performance, which is a normalized score, a return, and an episode length, but you can put whatever you want here. Usually there's going to be some sort of client struct. This is not required. You might want some structs for representing various states, like the agent or the goal, not required. And then you get the environment struct, which we expect you to have a struct for your environment. It's C, there are no classes. This is what you're going to have. What's up, Kevin? We're doing a quick tutorial live. You must have a log here. It must be called log. Do this. You must have obs, actions, rewards, and terminals arrays. Like this. Do it exactly like this, except you're allowed to have different data types for your observations. Make sure it matches the data type in the .py. You're allowed to have int or float actions. Make sure it matches the data type in the .py. If they do not match, you will be sad. Anything else you want to put in here is whatever else you want to put in here. In particular, we added these params to tell you environment specifications. This is what was getting set from the binding file. And this is the init function that we were setting from the binding file. C is very scary because you have to manage memory. Let me show you how scary it is. You call your allocations here in init, and then on close, you call free. That is it. That is the entire scariness of memory management in C. Lo and behold, you don't actually need to allocate memory 99% of the time, except when you're initting your initial environment. And then from here, we pretty much just have arbitrary environment logic, which looks like literal freshman CS 101, okay, maybe CS 102 because it's your first systems course, not your first general programming course. But the actual logic is going to be very readable here. Here we have a function to set new goals. It takes a pointer to the environment. It loops over agents because loops are fast. It loops over goals because loops are fast. And then it's just going to say, hey, if the puffer is not close to the goal, keep going, or loop out. Otherwise, if the puffer is close enough to the goal, we're going to set a new goal, and we're going to add some variables to the logs to say, hey, that we hit the goal, and this puffer has reached where it needs to go for now, and create a new goal. Observation computation. This is the thing that writes directly into shared memory. You don't have to do anything whatsoever special in order to make it do that. We loop over agents. We loop over the number of obs in here. Make sure that you are accessing like the correct addresses in memory here. Like if you have 12 obs and you're writing outside of bounds, you will be sad. But as long as you're not doing that, the actual code here is quite simple. You go over goals. We check distance to goal. That seems like a good type of observation to put in. Distance to other agents. That seems like a good type of observation. And a few things about the current agent as well. That is your entire observation calc. Reset function. We randomize the positions. No big deal. Don't forget to recompute obs. Have a little helper method there, and then here's your step method. Lo and behold, we loop over agents. Don't forget to zero out buffers. You would like to zero out your reward buffer. If you have an environment that resets, make sure you also zero out your terminals here. C does not zero out buffers for you if you don't do it yourself, so you do it here. Going to be the theme of things. This is the physics, if you can call it that. The agent goes in its heading at a specific speed. Here's the position update. And then every so often, we reset the agent. In really long-lived environments, it's pretty helpful to just jiggle the agents once in a while. Update your goals. Compute new obs. That's the entire logic of this env. The render code is one screen. God bless PufferLib. Env client is null. Then we make a client. We load some textures. And then here's your draw loop. We just clear the background. We go through the goals. We draw a star for each goal. And then we draw a puffer for each agent. And we flip the puffer right here. We flip the puffer in the direction that it's like facing in. Here's your close function. It frees some stuff. It unloads some textures. That's it. That's your entire logic. That's all it takes to write a high perf environment in C. Now, the one other thing I want to mention here is there is a .c file in here. And this .c file is kind of cool for two reasons. First, whoops. First, if I run this, you'll notice the puffers are actually doing things, even though it's pure C. How on earth is it possible that these puffers are smart without PyTorch? Because this is just C. Well, we have our own little mini version of PyTorch that we use and we can load weights into. This is what we do for our web demos. We compile these networks to WebAssembly. This is kind of complicated. You don't have to worry about this if you're just designing environments for personal use. We just do this for our demos. But as you can see, it's not actually that much code as long as you're using a standard network architecture. If you ignore the things that look like LSTM or network or whatever else, then the only thing in here is making a struct out of the environment, calling init, allocating your buffers, and then it's reset render, step render, step render. You could replace this with random actions, right? Like this, random actions. And the reason that this exists, other than the demos, is because I don't suggest that you try to recompile everything with Python every time you want to do this stuff. I suggest that you do all your environment dev in C, including the build, because the build is instant. You don't have to wait for stuff to recompile. You get actual proper C messages, and if you use this local flag, you will actually get sane error messages too, with address sanitizer and everything else enabled for you. If you compile it with fast on, it'll be way faster, but you don't get the nice error messages. It's plenty fast either way. That is all you need to know to write high-performance environments. That is pretty much the entire set of techniques that we use across like all the much more complicated environments. This is not the martial art where there are 1,000 different kicks to learn. This is the martial art where there's one kick to learn and you just get really good at it. Any questions? How do we have one model with 128 and another with 64, like a smart and a dumb puffer? That would be moderately annoying to do, Kinvert. That would be moderately annoying to do. You could hack something, but it's not like a standard feature that we plan around. Does anybody have questions on the actual tutorial? Oh yeah, I promised this guy a summary as well for his meeting. Let me go write this guy a quick paragraph summary for a quick paragraph summary because I totally forgot to give him one for my talk tomorrow. Okay, let me go write these guys a quick paragraph, and then I will answer all remaining questions. How to sweep. I will show. Let me answer all these in 1 second. I will answer all the questions in one moment. I'm sending this guy a quick title for my talk and a quick bio he wanted. All right, I sent this guy a quick bio. Let me answer all the questions. Come now, bring me your questions. I will answer them. In your opinion, why does scaling network size not improve performance in PPO? Kevin, it actually very much does. It's just that the cap out is way lower than you would expect. Like the trade-off between compute and data exists. It's just that it skews way more towards data than you would expect. Like if you're coming from supervised learning. How to sweep. You just run, like, instead of puffer train, you run puffer sweep, and it sweeps. You just have to set up either Wanby or Neptune, and you can pass dash dash Wanby or dash dash Neptune. You can give it a tag, and it'll run all the experiments for you. How is shoulder? Shoulder is annoying. If I do even machine press of like 100, it starts hurting. I really need to just dedicate some time to like doing, a bunch of rehab exercises on it. I have a custom gym environment and I want to transfer to PufferL. Should I use PufferL in Python? Convert to C? You definitely want C. The C is really, really easy. Just like follow my tutorials, and I promise you it'll be a lot simpler than you'd think. How do I avoid nans and puffer? That is actually mostly my fault, not yours. It tends to happen, well, if you have egregiously bad hyperparameters, it can happen with discrete, but typically you get it with continuous envs, and It's just like the hypers are more sensitive, honestly, because we have working stuff with continuous as well, but it seems like it's more sensitive, and there's probably like some additional clip terms we need to add for continuous envs to make it more stable. So that's kind of partially my fault. All right, FBR, you troll. Wouldn't you like to know? Where can I find tutorial for transferring my environment? So, a couple places. One, if you scroll back in this video, I literally just did, right, the full walkthrough like 15 minutes ago of a C environment. If you go to our docs, there's literally only one tutorial on the docs. Writing your own 1 million step per second environment. This looks really short, right? But the thing is, it links to everything. So this is pure Python demo. This is C demo of simple environment. And then down here as a second tutorial, right, is the one that I just went over, and there's even a template that you can use as a starting point. So I don't know what else I can do other than give you, this is like literally one page to read, and then code as references. And this tells you everything. If I have a paper with code that was done using offpol, but I want to transfer using Puffer, using algos with Puffer, you'd mostly be trying Puffer's implementation with the environments used in offpol research, or you would be like using fixed environments and then messing with Puffer to like adapt the algorithm. I don't know what else you mean by that. I think it happens if we start acing an env. Makes sense. I don't think it's just when you start acing an env. It's some weird thing. Trying to replicate using stack. Well, do you want to replicate the algorithm? Like, do you want to replicate the exact thing in the paper, or do you want to replicate, like, do you want to solve the environment, right? Because Puffer is not a repository of a whole bunch of different algorithms. Puffer just has the current best algorithm that we know exists, right? You can, like, the Puffer thing is Puffer's one file, right? So you can cut and paste like chunks of algorithm implementations into it and run experiments, and then Puffer gives you a really, really fast way to run experiments, right? You can totally do that, but you're not going to have like Puffer sack out of the box. Yeah, you basically treat Puffer like CleanRL, where you just edit chunks of the code, and it's maybe like twice as hard to edit Puffer as it is to edit CleanRL, because like editing CleanRL is completely trivial, right? But then the thing is, Puffer is 100 or 1,000 times faster, depending. So it's like a decent enough trade-off. It's a heck of a lot easier to edit than anything else other than CleanRL, that's for sure. It's basically as close to CleanRL simplicity as I can get it, but fast. Did I answer all the questions? I think I got all the questions. Messing with Puffer to adapt algo. It's pretty easy to edit Puffer once I figured it out. Yep. Honest opinion about SB3. Well, it was better than OpenAI baselines, which is like SB3 is really old, right? So when I say like SB3 is bad, I'm not saying that like, hey, the author is like, was it Francisco? Yeah, I'm not saying the author's an idiot, right? That's not what I'm saying. There are projects where I am saying that the author is an idiot, but this is not one of them. So the thing is that like, this is really, really old, okay? And it's like successor to stable baselines, which was a fork of OpenAI baselines, which was the original implementations of these algorithms, and these implementations sucked. So like it was a lot of incremental progress of trying to make this code not suck while not breaking the algorithm, which is incredibly finicky, even more finicky than it is now, right? And that was really hard. Now, I think the better version of this was Costa's CleanRL, which I actually don't know when Costa originally did CleanRL. This was like the totally visionary project, right? I actually don't even know how old this thing is. Can you see somewhere? If you do, I mean, it's like a ton of commits. But yeah, this was the genius one. Now, there are other projects like in RL that are just like stupid and bad, which are basically ones that had the advantage of seeing CleanRL and SB3 exist and made something even worse. But yeah, SB3 is bad by today's standards. It was very good compared to the original baselines code, right? Like nowadays though, you'd be pretty stupid to like start doing stuff in SB3 though. If you don't want to use Puffer because Puffer's like too complicated for your tastes, first of all, SB3 is more complicated than Puffer. So if you want something simple, you'd use CleanRL. That's what you would do. Okay. Has anybody got me a shader? I see Mechanics has just sent me a shader. So XF8, I do have to be clear though. The JAX thing, so if you want to use JAX for training, and you wanted to like port Puffer to JAX because you like JAX, that's like, I think it's kind of a bad library and it's really unstable and it's not actually faster, but that's kind of up to you, right? You can defend using JAX for training. If you use JAX for environments, you're trolling. You're just straight trolling. There's literally no defense whatsoever of using JAX for environments. So there's the information for you. Let me get Mechanics' shader thing, and we will go back to this. Yeah, he's JAX for environment. If you link me, so it just ate your link. But if you're gonna link me, the only good ones I know of are like Craft Axe. So that is what happens. Is it? Wait, which one are you linking me? Just give me the name of the environment. YouTube's gonna eat links. Is this supposed to do something? This takes additional resolution thing. Why is Crafter and NetHack good for RL? So Crafter is not good for RL. Crafter is terrible for RL. CraftX is like decent for RL. NetHack is not great for RL, but it could be amazing for RL with a little bit of eng work that I have not had time to do. Neural MMO 3 is really, really amazing for RL, and if multi-agent is not a problem, then you should just be doing it, yes. Neural MMO could be even better for RL. The network architectures limit it to, like, I've gotten 500,000 training. NetHack is way harder than Neural MMO. NetHack is a better environment, it just needs some eng to make it fast. This was adapted from Xord had on Shader Toy. Oh, okay. Do we need the resolution, though? Wait, why do we need... So I guess we just have to add resolution in, is that it? Gabe. Is this it? Where's the end? Where's the speed tests? Cool env. But where's the, when you say it's super fast, where are the speeds? Oh, okay, that's pretty solid. $2 million. 10 million is very solid. Single layer transformers. I actually don't know how many params that is. Though I do know for sure that that does not include CraftX, because CraftX itself doesn't run that fast. Okay, because it's a very simple environment is why. Yeah, so, okay, very well. I will explain to you then what this is. So first of all, 10 mil is actually very good. So 10 mil is very hard to get. We currently get up to 5 mil at the moment. That is with FP32, though. So we don't actually do BF16 a bunch, because it's usually nerfed on this, though I will be probably doing compile stuff for this. There's basically no other projects that do, like, that speed is just non-existent just about anywhere, and there are going to be some limitations here. So here's the problem with doing this in Jax, right? When you try to make this environment more complicated in JAX, it gets slow and there's nothing you can do about it. Because GPUs are not designed to do this, or at the very least, like JAX is not designed to do branching logic for more complex M's. The proof of this is Crafter, or CraftX specifically. This is made by a very talented author. The code is horrendous to read compared to what it would look like in C, and CraftX Classic gets up to 1/4 mil steps per second, and CraftX gets up to like 100,000 steps per second. So, and it's harder to write code like this. So that's why you don't do this. I actually have something that is going into the next Puffer update that I think will get us far above 10 million steps per second, with environments that are not going to be limited to being this simple, and that will actually potentially even stick some of them on the GPU. I am actually very curious, though, about this single layer transformer thing. Is this a temporal transformer? Or is this, yeah, is this a temporal transformer? Was it that will get you that fast in those environments? So, we're basically just gonna do some compile shenanigans, Tim. And I actually think we're going to play with GPU environments, but I'm not going to use JAX for them. I'm literally going to take the C code, and I'm going to copy paste it into a .CUDA file, and I'm going to run it, and I'm going to go. Because that's all you got to do. Is there a paper with this? There is not a paper for this. Well, the perf on this is actually quite good. I don't, like, this thing needs to actually have some benchmarks, because I don't know how big the nets are. Right? Oh, this is actually very, very good. Like, the stuff he has in here. It's a lot of files for something this size, though. There's definitely some good stuff in here. There's very definitely some good stuff. Who is this guy? Gabriel Keith. Is he on X? Self-taught. Huh. That's funny. Well, this is one of the more capable things that I've seen. He has it on the website. When did he do this? Yeah, I mean, this is definitely one of the more capable things I've seen. So the one convenient thing about JAX, right, is if you're not going to do CUDA environments, like if you're going to do CPU environments, you actually need some of the stuff that PufferLib has to make them fast. Whereas with JAX, you just need JAX. But the thing is, JAX makes your life miserable in order for you to be able to do that. So, but yeah, I can't say anything bad about the project overall. This is like very, very capably done. You just kind of may give yourself a headache with the jacks. Can we even get some of the code? Does this look fun to write to you? Like, does it, like, seriously, does this look fun to write? It's all array ops. The entire logic of the game has to be array ops, right? So that's why you don't do jacks, is because then you end up having to do that crap. And it doesn't scale. It's very capably done. I'll say that. It blows away most of the top lab things that I see. Running M-fast implementations. Making RL fast is becoming trendy. Now we got PufferLib. Next version of PufferLib will be much faster as well. I will give you like that's one of the better jacks things I've seen, but the limitation is that the environments are pretty simple, right? Jack starts to bite you when environments get more complex because it makes env dev hard. And the thing is, the vast majority of dev in RL, like PufferLib is a few thousand lines of code and then 50,000 lines of C for the environments. The vast majority of the code is in the environment. You really don't want to make environment dev hard. So that's why you really don't see a ton of complex, interesting M's in jacks. Because it's a pain in the ass. Okay, mechanics. What is up with your what's up with your shaders? Why is it like this? Yep, that's a successful compile. It's just gray. By the other two? Well, wait, this has a resolution to it. You straight up showed the trash after I asked you about jacks? Yeah. Because it makes your life miserable. All right, here, let me show you, right? So, CraftX is in jacks, right? And that's like one of the probably the most complex M's out there, and it's slow. So there's still 0 fast complex M's in jacks, right? This runs 1.5 million steps per second per CPU core. This has a leveling system, this has hostile enemies, this has melee and ranged weapons, this has an equipment system, this has a market with in which agents can trade with each other. I would not want to implement this in jacks, would you? As it is, any freshman undergrad can read this code. This code is like brain dead simple C. You read one file top to bottom, that's the whole entire environment. And by the way, I'm not limited on complexity here. So once we solve this, there's going to be a neural MMO 4 that's going to be way more interesting. And maybe it's like 5,000 or 6,000 lines of code, right? And it's going to be really easy, simple code. And it's not going to be hard for me to write. Because I wrote this when I was brand new to C. Brand new to systems programming, having done Python and nothing but Python for a decade. So this is why I don't like JAX, right? This is why JAX pisses me off. Because JAX pushes us away from doing things like this. I want RL on more interesting, complex environments. I don't want RL to get faster, but only on simple, stupid environments, right? It's got to get fast and complex. How far does current solve get? About a third of the way. This policy that you're watching here is better than I am at the game. It gets a little bit, it kind of gets a little bit aimless when it doesn't have anything immediate to do. But mechanically, it's better than I am, and it gets about a third of the way through the game on average. Why jump from Python to C for the RL here? Well, the training is not in C. The training is just PyTorch. It's optimized PyTorch, but it's just PyTorch. You could defend using JAX for training. I think Python is generally cleaner, but you could at least defend JAX for training. You really can't defend using JAX for the environments. Does it need to do anything to not die? No, it cannot starve. It does have to avoid enemies. The other thing is that this policy, this is a port of the policy to C so that I can put it on the website. So there are a couple errors with the policy. It's a little better if you run it locally. If I just, can I hit control? Yeah, I can take over for this guy here, and then I'm going to give him control back. So now I'm not playing anymore. So now he's unstuck. How on earth did you know Neural MMO 3 would be RL solvable before writing all the time writing that? If only I'd done a PhD on that exact topic. And to be fair, that's me being arrogant. It really wasn't solved for quite a while. Like, the initial policies were very, very bad at this. I didn't even do a ton of work on this from Puffer 2 to Puffer 3. I kind of just improved the algorithm, and the agent got better. How'd you get this deep into RL? Been doing it for a decade. Almost a decade. Over a decade for ML in general. Carbon, if you're interested in RL and you're trying to get involved, I do have educational materials as well. They're free. They're just on my X tab. This guide is a very, very easy way to get into RL. There's a lot less math than in Sutton and Bardo. You should still reference Sutton and Bardo. But this will get you building RL environments and actually training agents in, like, you know, hours to days. Pretty much everybody who is new around Puffer got started with that stuff. And most of these environments are made by contributors. Barely started with Docker and Kubernetes. Man, I don't know how to use Kube, okay? Like, you don't need to know how to use Kubernetes to do this, like, at all. You need to just know basic low-level systems programming and some AI fundamentals. Oh, Carbon, it was really cool back then. It's not cool now. Now it's, like, lame because of LLMs. Back then it was, like, Dota. That's when it was cool. Have I missed the tutorial? Yes, Jess, but you can just scroll back in the VOD. Wait, let me answer some questions here. SB3 runs 10,000 steps per minute. That is garbage. Yeah, so Neural MMO 3 trains at 500,000 per second on one GPU. Most of the M's in Puffer train at millions. How long did the train this policy? Yeah, so everything except Neural MMO, you don't have to train for very long. Neural MMO is the hardest environment. I trained this for 650 billion steps, which was like 3 days on a 6 GPU box. Pretty much everything else you can train something cool in a couple of minutes. You started the PhD not knowing? I'd already been working on Neural MMO for 2 years before I'd started my PhD. Hey, Asa. Thank you very much. Oh yeah, there's the Discord as well. Yeah, for folks who are new around here, Start the GitHub. It's free. All this is open source. It helps me out a ton. And then everybody's just on the Discord. If you're trying to get into RL, you just follow the guide and you start building cool environments. And you get RL to work on them. You PR some of the environments. More environments get added to this. And then more environments get used for research. And then once you've done a few of those, you can actually start on some of the research side stuff as well. But the easiest and most fun way to get involved is just to like jam some low-level game dev and see RL actually work on something that you've made. My agent is not improving. Should I sweep more, increase model, try different architecture? You should debug a little bit to make sure that you don't have environment problems, because almost always it's an environment problem. And after that, then you should just run sweeps. Yeah. Everyone builds RL agents. You have an agent that's better than everyone else's. No, everybody does LLM RL now. Very, very few people do what I do. Multi-agent PPO and use Dota for a benchmark. How to deduce per take. Use Dota for a benchmark? Wait, what are you talking about? Like, OpenAI 5 beat top pros at Dota. That is, in my opinion, the best result in the field. Feel a lot of your ideas. I'm going to genuinely get 10 FPS. Yeah, a million FPS. 2 years before and get younger. I actually, technically speaking, the first time I tried to do neural MMO, I was 16, maybe 17. I had no idea what I was doing, so it failed horribly. I tried it again when I was like 18, and I still didn't know what I was doing, so it failed. And then I tried again when I was, I think, 19. Yeah, 19 or 20. Maybe 20. And then that became my PhD. PufferL's a gem. Thank you very much. To debug, I tend to render in printf. Okay, convert. At least use GDB. Okay? At least use GDB. What's the difference between what you do and everyone else? Because almost all the discussion about RL these days is LLMs. I do everything but LLMs, right? Most of these models are between 100,000 and a few million parameters. They're these tiny superhuman models. You can train them at home on your desktop. Actually, you can see all my servers right behind me, right? Like, I got the couple of white boxes up there, the 6 GPU tiny boxes, and then the rest of those are just standard desktops. Google APIs to mine YouTube. What? Trying to keep up with the latest research channels. You don't actually need to consume that much content to learn this stuff. You basically just need a couple sources of content that isn't wrong. RL to improve LLM. Yeah. So, Carbon, it's like RL to improve LLM perf, basically. Like, that's the main stuff that people are doing these days. So, this is one of the only places. Honestly, I think Puffer is now the biggest open source. At least it's the fastest growing open source RL project at this point. Right? Like, this is the growth on Puffer. Right? This is when I started working on it full time. This is like right when I graduated. What was a mistake you learned relatively way later? Not doing low-level dev. Like, literally just spending too much time being stuck to Python and not doing low-level dev. That was a huge mistake. Like, this is one of those things that I'm so confident about. I will be just like, just put your opinion aside. Like, go follow the tutorial, do some low-level dev. You will see that it is very easy, and you will see that this is actually the smart way to do things. I don't think I've had a single person say, actually, I think I'm going to go back to writing these things in Python. Or actually, I think I just want to write jacksems. I don't think I've had a single person do that. All right. Let me use the restroom real quick bench set, and then we're going to finish the shaders, okay? I'd be back. Never want to not use puffer. Benchmark off Paul. Tim, I tried a lot of off Paul stuff. None of it worked. Like, I tried in puffer, I tried a ton of popular repos. Basically, all the impulse suck. It's kind of just rough. No, that's what we see during training, Jess. That's not eval. We can get neural MMO to 500k. Like, proper. And we can get a lot of the simpler M's to like 3 to 4, sometimes 5 million. Alright. Getting some decent sets in today. Bench strength is not coming back as quickly as I would have liked, though. I think I just gotta bench more. Anything? Nothing here. I'm on his reading list, it looks like. That's fun. Try the shader I've highlighted. What have you highlighted? Try this next. Okay. Okay, this is... I mean, this still has the dark circles around it, doesn't it? I guess it does kind of stand out nicely. I guess I'm gonna make some small mods here. The dark circles are dependent on what you discard in the if statement. Is it just blend mode? Like, do I just need to set the blend mode to something else? Well, that's glowy looking, right? Yeah, that's real glowy. I can't tell if it's still... It looks like the 2D ones still have the circles and the 3D ones don't somehow. I don't know how that makes sense. Let's see if we can make this pretty now. Get my headset back. I got 1 hour of dev left in me for before dinner, and I'm probably gonna do a night stream as well. I'm feeling good on dev today. Yeah, but I still want the blur effect. Oh, I'm dumb. Hang on. Watch this. You're like much more alive than during that cut. Yeah. So, alright, Dude, do you understand what a 1500 calorie a day cut is? Like, so a 1500 calorie a day cut is like, if you're a pro bodybuilder and you fuck up your diet so that you need to get on stage and like you don't have as long as you think, that's what you do. It's completely psychotic. That was kind of the point. Is I wanted to set myself like a totally psychotic thing for that block of fitness. I'm actually still dialing in calories right now. I want to be at a slight bulk. I think I might be at maintenance and I might need a few hundred more a day. We'll see. I mean, it worked, to be fair, right? I got cut in like 6 weeks. How are user stats calculated? User stats are everything that goes into your log field and it gets aggregated across all envs. Only at the end of the env? Nope, it's whenever you specify... It's whatever you specify in the environment logic. So all that our logging system does is it gives you a spot to store logs, and then it handles accumulation across envs for you. You can write whatever you want in there. Usually it's at the end of episode, but not all envs do that. Not all envs have episodes. Carbon diet coach. So, Tim, I have the opposite problem. Diets are easy, bulks are hard. The whole reason I did a 1500 cal cut is because it's like, I know that that is something that is relatively easier for me. If you try to make me do a 1500 cal bulk, I'm dying. Alright, this fixed it. Yeah, the blend mode fixed it. Mechanics. So thank you. This is actually a very nice shader now with this. I don't know if this is exactly like the other one, but this is a very good start. Bulk cut, maintain. Yeah. I have some assistance on that already, though, Tim. I didn't over the summer. Over the summer, I was just kind of doing my own thing. And I just did my own thing, and I hit my target to the pound. So, love opinionated advice in the guide docs. Well, because it's like Carbon, if I don't give it opinionated, like, nobody listens, right? If I tell you, you should consider doing X, everybody says, oh, yeah, yeah, okay, and then they don't do it. If I say, you're an absolute imbecile if you don't do X, then people listen, right? It's like one of the hardest things as well when you're learning is like nobody giving you a straight answer with the appropriate emphasis, right? Like if you talk to world-class people and you ask them for advice, but they say a lot of stuff and they don't actually accentuate like what portions are important or not, you go nowhere. So I'd way rather give useful advice than worry about pissing people off. Plus, it's more fun. And sure, you know, you can come off as a dick sometimes that way if you're just listening to how I say stuff. But, like, if you actually look at the result and look at whether it helps people learn things or not, it's a very different story. Right? Okay, this is sweet. I think we can make it like twinkle. Twinkle, twinkle, little star. Yeah, that's, I mean, I just want no noise, right? I want tech to exist. So build it. It's a sign function, but I also need to add an index, man. I think I need to add an index, right? Figure it out. Mm-hmm. How do I add a thing to this? It literally is AI research is the thing. Like, that is the straight up best way to get into RL right now. Because you will get practical experience with training agents, and that will help you incrementally get to the harder stuff. How do you prevent your back from sticking to the chair after all that sweat? I'm not sweating. I'm doing a set every so often. It's not cardio. I do my cardio in the morning. I actually hate being, like, at my desk in, like, a proper chair being all sweaty and gross. So, like, my training is, like, you see me, I go do a bench set and, like, a set of cable curls or whatever. And I just do a bunch of that throughout the day. We did have this 50 set workout on Sunday. That was fun. Alright, let me actually get this done. Because, like, I want to have this thing working today. How the hell do I add to this buffer? Shader.lux. Right, so this needs to be... That's position and color, isn't it? Wait. Wait, why are there are 2 pointers here? Oh, wait. Current time. Oh, because this just doesn't get the period at all? Oh, it's smuggled into Z. Okay. Oh, but then I can easily do this. Wait, I can hack this. Yeah, this is easy. Instead of period, this is going to be I. I think you got it to work. Yeah. But I'm doing something slightly different from that. It's the current time, right? Uniform. Right, so this was the weird thing. I am just not passing the current time somehow. Where's the camera matrix thing? What's it called? MVP? Thanks for doing these, of course. Hey, I get stuff out of this too, man. Like, most of these environments are written by contributors. I'm a little bit behind on merging PRs, but like, the M's are really super useful. I have a whole bunch of them sitting that I gotta review, and those are gonna go right onto this dashboard as soon as I do. More experiments. Oh, I am just stupid. Right? Does this not work? Ooh. Glittery. There's gotta be like some decent well-known function for this, right? see this. Actually, I can just see. This thing compile? Yep. What would be the best companies to get into the companies? Not a master PhD with companies. So first of all, nobody gets a PhD in data science. That's not a serious thing. People get PhDs in AI or in some area of AI. Bay Area of the US. Like, just be really good and get, like, noticed is pretty much it. I'm not a good person to ask for traditional job advice. Because all I'm going to tell you to do is be really good. Like, be good enough to be noticed, right? Use RNN or LSTM. Wait, what? For what, E10? For nonogram, use an LSTM. Always. Publications, yeah, or research. Yeah, pretty much. Performance by board size. 95, 98, 96. Okay, so it's weird that it drops to 0 like that. It should not have such a sharp fall off to 0. Unless the learning curves. I guess if you did the obs the way that I suggested, then it's possible that it does this. Is it training on 5x5? Like, how do you have curriculum set up? Yeah, Arash, the thing is, the advice I don't want to tell you, but is probably true, is you have to actually be good at taking interviews. Which sucks, because getting good at interviews is not the same as actually being good. I don't have a way around that, though. Same stride for all boards. Whoa. That's crazy looking. Not super helpful, but crazy looking. We'll make this actually look good and, like, useful. That's kind of nutty, though. Use the same strides, the chords mean the same thing. I'd have to look closer at the ob space. I'd look at the learning curves, though. Ethan, can you plot the, so just log the perf at each size over time, and you'll get a train curve to basically see, because if it's just like, if it's like flat 0, and then it just pops up to 100 for size 1, and then 2, and then 3, and then 4, then that's normal. It's just like, okay, you know, there's nothing wrong. Means applying with a really nice portfolio. No, it doesn't, Arash. There are technical interviews as well. Which should not exist, but do. Yeah. Perfs v steps. Perfs v, or perf v cost, either way, yeah. Dynamically have stats change keys. No, Ethan, you would just allocate, like, just make fields like 1, 2, 3, 4, 5, 6, or whatever, and just use the ones you need. Grad jobs, ignore your GitHub and do keyword search. Yeah, that's the problem. Like, I'm not a good person to ask for that, right? I'm very much like an outdoor guy. Like, I'm an outdoor nutty kind of type with this. And, like, yeah, I have traditional credentials. But guess what? I probably would fail a, like, literal first-year software engineering interview for Google. Which I could have done when I was 18, by the way. But, like, that just kind of shows you how far off these things are from the actual practical of how to do stuff. Okay, I mean, we can tweak this, but that's star chart. Real quick. Ooh. Yeah, the annoying thing, Ethan, is that comes at the cost of spending time practicing actually getting good at stuff. Do you think choosing a different color for some of them would be better? Yeah, it's gonna get even harder, though, is the thing, because, like, we're gonna have more colors than this. So I don't want it to be a total noisy mess. We should also add a tick box for shader, right? We'll add a tick box to enable or disable shader. Cause like this is fun to look at, but probably if you want like a static plot, you just like have it off. Obviously on by default. Yeah, you're sadly right about that, Ethan. How long did Puffer 4.0 take? Well, it took 6 months and another 2 for Twinklies. This took me a day. Not even. I've done other stuff today as well. And I have a couple more hours. I got half an hour till dinner, and then I'm coming back for a night stream. Most likely. Like, this is not even fully tuned yet, and this is already pretty freaking cool, you gotta admit. I'm trying to think what we do from this. Kind of convert, not really. It's not an event-based system. Yeah, I gotta tune it mechanics. Let me get the colors first. Okay, so this just gets to be disgusting if you do it this way. Apparently. There might be a built-in I'm missing. So value is brightness. Start with really simple. That's kind of what CL's for. Ah, got it. PufferLib literally has it. Go away. Man, Rayson is just the best. Okay, if it works, that is. Oh, because its hue is to 360. Okay, so here, hang on. We just write a little wrapper, 1 sec. Why is this white? Saturation and value go to 1. White saturation? What, do I have to set them both? Oh. Wait, I'm confused. Why can't I do this? Oh, I just didn't scale it right. Darken them. This looks cool. I mean, obviously you can't tell them apart right now. Looks cool, though. Let's tune the shader a little bit. That's way better. And a few of them are twinkling. And the frequency. Tiny Grad kinda does, yeah. None of the really big ones are good, I don't think. Green looks ace, yeah. But you can't tell what's going on. I think I can make it like a default or something. We are gonna do a night stream though after this, so we'll have more time today. I'm feeling good. I'll probably take like an extra 10 after dinner to get a few more sets in, because I haven't done enough of that today. But other than that, we're gonna get a night stream in. Ah. Can you redefine a macro? Yeah, you can. Easy. That does not seem to do anything. Why not? I included it afterwards. Yep. This update camera has... This has orbital speed. Really? Why does this not work? Undef. Oh, undef. Still no? That's kind of weird. Well, I guess I can just do my own little camera, right? It's just an annoying chunk of code. Oh, our camera. This is weird. Got 13 minutes till I'm off. Yeah, I got dinner in a few. Actually, this is a good time for me to mention for folks. If you are new, yeah, let me actually do outro here now. I'll keep working until I got dinner, but if you're new around here, all my stuff is free. It's open source. It's on puffer.ai. This includes all my latest research as well as the end stuff and educational materials. So if you want to help me out for free, just start the repo. If you want to get involved, join the Discord. There are lots of helpful people here, and you can follow me on X for all that content. My articles are there as well. That's the best place to read them. This is my articles tab. Most of these M's are made by contributors, many of whom are brand new to RL, so good way to get involved. Camera orbital speed. Oh, it's totally a scope thing, right? No, we'll just... We actually don't even need most of this. It's not going to be that bad. We'll just do it like this. Here. And I don't need anything that's not orbital. This whole else block. Literally, this goes away. Third person or orbital. Yeah, so it's just this, right? Go get their defaults. You doing a night stream? Yeah, I'll do a night stream, Jess. Give me 30, 40 minutes for dinner. I'm kind of trying to, like, finish this stuff, right? Oh, is this all it was? Is the rotation speed? Yeah, we'll see. Why don't I have access to these functions? Alright, I gotta go, folks. I'll be back after. We'll fix this then.